All right, so when we have more than two rational expressions, we have no choice but to go into common denominator mode to solve it, but the common denominators can be a little tricky to find. In this case, the wrong way to do this one is to multiply everything by x squared minus 4x, and by x minus 4, and by x. That's inefficient and causes a lot of problems, and I'll show you why. If we factor our denominators, x squared minus 4x factors to x minus 4, and our next term has x minus 4. So these two have something in common. And our last expression also has something in common with the first one. So these two both have x minus 4, and these two both contain x. That means when you go to do your common denominator, you're thinking, all right, all of these contain an x. I must multiply by that. And these two contain x minus 4. I must multiply by that. You don't have to do any of these things twice just because they appear in two different expressions. Just the fact that they appear anywhere means that they're part of the common denominator. Okay, so I see an x here, everybody gets an x. I see an x minus 4 here, everybody gets an x minus 4. This fraction contains an x minus 4, but it doesn't matter. I've already dealt with that. And this one contains an x. I've already dealt with that. If you don't factor this piece, you end up overkilling and multiplying by things twice. If you'd multiplied by x squared minus 4x, you'd be giving these things an additional x and an additional x minus 4, which they wouldn't have needed. What we just did is enough, because look what happens. These x's cancel out. These x minus 4's cancel out. Here the x minus 4's cancel out, and here the x's cancel out. Our denominators are all gone. And now we have 16 equals 4x minus x minus 4. Be careful here, this negative sign belongs to both pieces of that bracketed term. I'm going to have to distribute it through before I'm done. 16 equals 4x minus x plus 4. 16 equals 3x plus 4. Subtract 4 from each side. 12 equals 3x. Divide by 3, x equals 4. See anything interesting about that? We haven't checked non-permissible values. I know the only time this has ever really gotten serious for us is in that question with the unfortunate Leo, but let's stay on top of it. You never know. Here we get x is not allowed to be 0. And here we get x minus 4 is not allowed to be 0, which means x is not allowed to be, uh-oh, look at that. They finally did it. This solution is actually not valid. The only algebraic solution we could find was 4, but at 4 this equation is undefined, and so in the end we have to say this thing has no solutions. Or they were using the term roots, so we'd have to say it has no roots. There's no number you can plug into this equation that will make it true. The only number that had a chance was 4, but if you plug 4 into this, you get 4 divided by 0. That's undefined, which means this equation is hopeless. Good thing we checked.